In this video we are going to explain how a machine learning model works. This information is necessary for you to perform the tasks required for our study. If you have never heard of machine learning and models before, don't worry, we are going to introduce the concepts you are going to need later on, when performing the actual tasks. So what is a machine learning model? A machine learning model is a computational model built by looking at historical data, so that a computer can learn how to make a specific set of decisions, in a specific context or domain. Don't worry, you don't need to know the details of how such models are built. You only need to grasp how a model is actually used to make such decisions and a little bit about how it works. You can imagine a machine learning model to be a sort of magic black box which receives some data as an input and produces an answer as an output. Let's take a look at a specific example. Now imagine that you work in a bank and somebody built a machine learning model to automatically decide which credit card applications from your customers should be declined, and which should be approved. Using the same diagram we have shown you before, you can now see that for this specific example, the machine learning model receives information about each application as an input, and it provides, for each application, a suggestion on whether the application should be approved or declined. Before we move on, it is important to clarify an important aspect about how a machine learning model makes such decisions. Each application in the credit card example is described by a number of predefined characteristics which we call features. Such features are used by the machine learning model to assign a specific suggestion, which we call a label. Still, we use the credit card application as an example. Here, each application is described by the features you see in this table, for example, credit history, and months since last delinquency. Here the model assigns to each application one of the two possible labels, either approve or decline. For the purpose of this study, you should then think of a machine learning model as an automatic procedure that takes as an input a specific set of objects and, by looking at the values of these objects, assigns to each one a specific label. Now that you have learned what a machine learning model can do and the concept of features, values and labels, it's time for us to provide more information about how a machine learning model makes such decisions. One way to describe this process is through the use of a set of rules. Using the credit card application example again. The way the machine learning model makes the decisions can be described by the set of rules that you see here. We have three rules, R1, R2, and R3, in this diagram. And when an application comes, if it has unpaid balance value larger than 36, then it matches rule R3, which suggests decline. And if an application has a value of bills paid on time larger than 92, and an unpaid balance value lower than 36, then it matches rule R2, which suggests accept. As demonstrated, the color of each circle represents different labels. Imagine that we have an application as shown above. Bills paid on time is larger than 92. An unpaid balance is larger than 36, so it cannot match rule R1. And for R2, although the application can match the condition related to bills paid on time, the value of unpaid balance does not match. And because the value of unpaid balance is larger than 36, this application matches the rule R3 and gets suggestion decline. For the same set of rules R1, R2, and R3, we can also present them in this way, where each row is a rule, and the condition is placed at a specific column according to the feature it uses. Similarly, if the application has unpaid balance value larger than 36, then it matches rule R3, which suggests decline. And if an application has a value of bills paid on time larger than 92, and an unpaid balance value lower than 36, then it matches rule R2, which suggests accept. For this set of rules, we can check those rules with suggestions that we are interested in. For example, we can find out the rows where the suggestion, accept, are given. Then we can look into the specific rule. Also, we can look at a specific column, and find out the rules related to this feature. For example, here we want to know that what rules are using conditions related to bills paid on time. So we check the column of bills paid on time first, then we focus on the rule R1 and R2 because they have conditions, bills paid on time smaller than 92, as well as bills paid on time larger than 92. Similar to the previous visual representation, here we still put a condition to a specific column based on the feature this condition uses. However, here we use a black rectangle marked with values to represent the condition. If the rectangle is marked with two values, x and y, then it represents a range larger than x and smaller than y. And if the rectangle only has one value, x, marked on the left side, then it represents a range larger than x. For the rectangle with only value x marked on the right side, it means a range smaller than x. For example, the third row represents the rule R3. If unpaid balance is larger than 36, then suggests decline. Before we move on, it is important to highlight a couple of things about how the rules work. In practice, an application may match multiple rules, or cannot match any rules. And then other metrics will be considered. But in this study, we guarantee that for each question we ask, you can find one and only one rule to be matched. Now that we have explained all the concepts necessary for our study, it's time for us to verify that you have learned them, before we can move on to the next steps. As soon as this video ends, please click on the Start Verification button to access the verification test. If you pass the test, we are going to introduce the tasks we need you to perform.